questions, problems, confusions, comments? Well, apparently one of my dogs has a comment. Okay, so of course, if anything comes up, let me know. So what we want to do is jump back into the work that we had begun on Tuesday. So I'm just looking really quickly at where we left off. I think, by the way, that I have to upload our Tuesday whiteboard notes. I will do that along with the recording of our Tuesday meeting. So I'm a little bit behind, but I'll get there. So we just finished off with introducing the truth definitions for the biconditional. So what did I do with my pen? Okay, hold tight. So let's do this. Let's just make sure that we're comfortable with the truth definitions, the aforementioned truth definitions. But as we're going to want to move into looking at the rules, intro and elim, for the conditional, the biconditional, and think about how those rules are based upon the truth definitions, let's just add, as a reminder, our Boolean truth definitions, okay? So this will be a quick review. Okay, here we go. Let me clean things up a little bit. Okay, so truth definitions. Why is this not working now? Review. Okay, so we know that, oh goodness. Hang on. Let me try something else. Well, I'm trying this something else. Let me know if you have any questions, problems, confusions. Okay, here we go. Yeah, whatever. We're done with that. Okay, so I think what I want to do, I think I fixed the issue. Let's see if that's true. Yeah, I did. Yay. Okay. Whew. That's a relief. Okay, so truth definitions review. Goodness sakes. False, true. P conjunction Q, P or Q. True, false, false, false. And then we've got our conditional and our biconditional. Question for you, by the way. How many of you learned your truth definitions by effectively like a rote memorization. I just, think about the possible truth values for the elements. I think about the rows, and I memorize the value for each row of the truth table for a given operator. And how many of you say, I learned the truth table by thinking about the concept of truth, the concept of falsity, the concept of the connective in question? So, for example, how negation operates on truth, negation operates on falsity. So I'm curious, how many of you worked mostly along the lines of the former description, and how many of you worked mostly along the lines of the latter? So how many felt like you memorized the definitions? Any folks memorize the definitions? How many thought about the concepts themselves and thought about kind of wrapping your head around the concept? Okay, so Victoria, yeah, the concepts, and then through the understanding, the definitions make sense. Is that fair to say? I ask for two reasons. One is I'm wondering if our discussion on Tuesday of what the approach to the truth values for the conditional, or the truth definitions for the conditional, works for you, how that approach went, right? And then if you have any residual questions about why it is, for example, that on row 4, both the antecedent and the consequent are false, and yet the sentence itself, the conditional, is true. What are we thinking? How are we doing? And then it seems like from the way you were engaging with the biconditional on Tuesday, that you've got a pretty good grasp of the interpretation of its truth functionality, right? Okay, so all of this should look familiar to you. Let's go ahead and take some sentences that let's just say already translated. We'll also do some translation work, but let's take some sentences that are already translated and work through the determination of the truth values for the sentence as a whole, which is to say, work from the atomic and then atomic sentences, subconnectives, to the main connective, right? And see what your comfort level is there. Okay, so hold on to these values. Have them in front of you if you don't already. And I will go ahead and generate a new whiteboard. And I'm just going to throw some sentences out, and let's see what we get. Okay, so first question is this: what is the main operator? Is it the first negation, the conjunction, the disjunction, the arrow, conditional, or the second negation, Good. And folks are saying arrow. Excellent. So that means that that's the last set of rephrase. So that means since arrow or the conditional is our main operator, the last set of values we determine are the ones under the arrow. It doesn't matter which side of the arrow we, in terms of truth values, we generate first, right? That said, if we choose the left side of the arrow to work on first, we need to make sure we know what is the main operator there. So what's the if you will, the secondary operator if the arrow is the first? Is it the tilde, the ampersand, or the V? Is it negation, conjunction, or disjunction? Oh, you were so quick on the draw with the conditional. What's the main operator for the sentence I just circled? I know I kind of included the conditional. I didn't mean to. Negation. Really good. Thank you so much. Okay. So then what we want to do is generate the values for negation last. So this is our main connective. If we've got, so hold on just a second. 1, 2, so this will be 3, and then let's go ahead and make this 4 and 5. Although 3 and 4 could, they don't have to go in that particular order. What about the conjunction and the disjunction, which is the main connective if only those two are in the are considered, I should say. Disjunction. Good. Thank you so much. So that means that we determine our conjunction first, then our disjunction, then our negation. All right. And remember, 3 and 4 could be, done we could do the negation Q first if we wanted to. Okay, so next question is, how many simple or atomic sentences do we have? Edward? Eddie? How many simple or atomic sentences do we have? I don't know how many Ed is counting. Thank you, Victoria. Yes, so we've got 3, right? Now, Arshak, you're right that there are 4 iterations, right? So there are 4 appearances of an atomic sentence. But notice, Arshak, that Q is repeated. So we've got 3 atomic sentences, or 3 simple sentences, which means we have a total of 8 rows, right? So the first, and we always go left to right, remember? If we have 8 rows, the first sentence on the far left, in other words, is going to take half true, half false. So true, 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 false, 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 false. Good, good. Okay. And then we Q the next one over is going to take half of the first 4, right? And we'll get 2 true, 2 false, 2 true, 2 false, 2 false. So true, true, false, false, true, true, false, false. And then the last sentence, regardless of how many rows we have, but the very last sentence gets or alternates true, false, true, false, true, false, true, false. 1, 2, 3, 4, 5, 6, 7, 8. Now, unless you want me to take the values from the first iteration of Q and plug those into the second, I'll just go ahead and refer back to the original iteration of Q. So now we're ready, right? So let's work the conjunctions. First question, Are there any rows on which the conjunction sentence is false? So let's go ahead and number these just so that you can give me line references. Okay, so what do you think? Is P conjunction Q false on any rows? And if so, which ones? Right, so I see Arshak saying 3 through 8. So, true, true, false, 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 false. If you're worried about, keeping the visual straight, I can always color code these. But I'm hoping that I can keep the rows as straight as possible. Now what we need to do is take the values from the conjunction and the values from R and determine the disjunction, right? So here's the same question. Are there any rows on which the disjunction is false? And to be clear, let's just go ahead and not be put off by the values we've already used. Is there any row on which the disjunction is false? I see, if I've got my rows right, I see 1, 2, 3. What do you see? I see 3 rows. Do you see 3 rows? And if so, which ones are we talking about? Yeah. Okay, good. Yep, Victoria, 3 rows. Which ones? Yep, 4, 6, and 8. So true, 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 false, that's row 4. True, false, that's row 6. True, false, that's row 8. Good, good, good. And then we're going to negate all of the disjunction values, right? So we take these values from the disjunction and we're negating them. So, I can get rid of these. So we've got false, 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 true. Sorry, that's not as clear as could be. False, true, false, true. And now we need to work on the negation Q, right? Because now we've taken care of the left side of the conditional. Now, here's something for you to think about. Knowing what the truth definitions of the conditional are, when you see on rows 1 through 3, 5, and 7 that the value is false, you know that the conditional is going to be true. Doesn't matter if the antecedent is false, the conditional claim is true, right? So we can just go ahead and write true, 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 and then we're going to skip a row. True, skip a row, true, and skip, and then we're done. So we need rows 4, 6, and 8. So one thing we can do is just generate the not Q values for rows 4, 6, and 8. So on row 4, Q is false, which means that not Q is true, which means that the conditional is true. Tell me if what I'm doing does not make sense to you. And also if you think I've looked at the rows incorrectly and got things wrong. Right? So row 4 is a true antecedent, and row 4, on row 4, the atomic sentence Q is false, which means that Q itself is not Q, sorry, is true, which means that the conditional is true, right? Now let's go look at row 6. Row 6 is true, right? The atomic sentence Q is true, which means that not Q is false, which means that row 6 is false. And then lastly, right, Q is false, which means not Q is true, which means that the conditional is true. How are we doing? What do we think? Does it make sense? Here's what I'm hoping is you say, oh yeah, I haven't worked on truth tables in a little bit, but yes, this makes perfectly good sense. And I remember, and I know how to calculate the values or determine the values and so forth. What do we think? Pretty good? So far, so good anyway? Sorry, I'm just knocking books over. Questions, problems, confusions? Thank you, Dominic. Good. Glad to hear it. Or glad to know, I should say. Okay, so let's take a look at some equivalences. So I'm just looking back at at the notes from the whiteboard from Tuesday, and we didn't really work any equivalences. So let's now work on some equivalences. Is it fair to say that this sentence is contingent? Right? Remember we have some classifications. We have sentences, an individual sentence can be contingent, it can be a tautology, or it can be a tautological falsity, right? So when we're dealing with contingent sentences, we've got mixed values. When we're dealing with a tautology, we have a sentence that's true on every row of the truth table in the column under the main connective. Assuming that there are multiple connectives or multiple operators. And then when we have a tautologically false sentence, we have a sentence that's false on every row, has a value of false on every row in the column under the main connective. Okay. So we'd say, oh yeah, the sentence is contingent. And in other words, it's not a necessary sentence. Right? Contingency versus necessity. So let's look at some equivalences. I thought for sure that I had, bear with me for just a sec. I want to look and see if I'm just having dreamt of stuff. Oh yeah, we did one equivalence, right? We worked the equivalence between the conditional and the negation of the left side of a disjunction. So let's go ahead and pick that up. Okay, so let's look at some equivalences. And I'm just repeating one that we worked on Tuesday, just as a reminder. And then what I'd like us to do is work from the symbolic logic notation back out into some ordinary English examples. So we know that these are the values for the conditional, for the arrow. And we know that these are the values for the disjunction. And we can see that these sentences are equivalent. They are tautologically equivalent. So remember, in a number of versions of the system that we're learning, truth functionally equivalent sentences can be used as rules of inference in a derivation. So if you, let's say you have a conditional claim, but you want the disjunction, you could just substitute. They're often called substitution sets or replacement rules or equivalence rules. You can substitute one for the other, right? And then they're mark a name for it, right? What we do though in our version of the system is we actually prove the equivalences. We demonstrate the equivalence through the proof process, as opposed to, let's say here in the truth table, we're just showing that they're equivalent. We're not demonstrating how. Okay. And in fact, if we look at our text, bear with me. Okay, so you should be, right now you should see chapter 17, section 4, where we're into the truth tables for the conditional. And you'll notice, so off to the right, I'm circling with my cursor the box, the pink box, where we get some equivalences. Like I said, we're going to want to prove those as opposed to simply say that they're equivalent. Look, a truth table shows us they're equivalent, and then we're done. We can use them as substitutions. We'll prove them. But what I want to make sure that we do is run the truth tables for them as well. So let's go ahead and grab, so that we want to grab, so the contrapositive. So notice that we've already done, so oftentimes this set of equivalences, if we use this as a rule, if we use it as a rule and a proof, the rule is called, often called implication. Here it's the contrapositive. Okay, so hold on to that. And then where's our, okay. Okay, so I don't want to waste your time looking around in the text, but I thought that in chapter 17 there were more equivalences, but no worries. I'll work the ones that that at least some of the ones that we should be able to talk about and then eventually prove. So we just worked this guy. Oops, hold on. Right, so we just worked P arrow Q, not P or Q. And then let's look at the contrapositive of that original statement. And sorry, my vertical lines are not super vertical. And here again, I feel like we did this last one, but maybe I'm just off my rocker. Wouldn't be surprising, right? So true, false, true, 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 false, true, true. Let me make the tilde look more like a tilde. And then now let's work the negation P arrow negation Q. So we've got false, false, true, true, false, true, false, true, true, false, false, true, yeah, true, false, true. Oh, you know what I just did? Does anybody see the error that I just made? I kind of paused for a second because I thought, wait a minute, this isn't coming out equivalent. What's wrong? What error did I make? And if you're not sure how to proceed, remember what we just saw on the remember what we just saw on the textbook site, right? The contrapositive. Did I write the contrapositive? No, I didn't. P arrow Q is not equivalent to not P arrow not Q. What should I have written? Anybody? 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 Yes, thank you, Dominic. Not Q arrow, not P. Okay, so remember, I think I mentioned this to you a little while ago, but I always tell people when we're working together in a physical classroom, hey, if I make a mistake and you don't correct me, it's your fault. Try that one on for size. Okay, so let's go back in and do this right. Sorry. So false, true, false, true, false, false, true, true. And then we have true, false, true, true. So get rid of these guys. And we see that we've got our equivalents. All right, you ready for another one? And then I want to translate out, right, to ordinary English. Okay, Dominic's ready for another one. All right, how about this one? This sentence we can read as follows. It's not the case that P is sufficient for Q. What do you think? It's not the case that P is sufficient for Q. Oops. All right, so main operators. For the first sentence on the left, is it the negation or the arrow? Is it the negation or the conditional? Is it the tilde or the conditional? It's the tilde, yep. How about the second sentence? Is it the first negation, the conjunction, or the second negation? And yep, Dominic, you're right. Sorry, no, I'm looking at your first stab. It's the negation and negation again. Good. Okay, so first we need to determine the values for the arrow. Since there's no other connective whose values we need to determine first, we just plug in our truth definitions for the conditional. True, false, true, true. And then we negate. False, true, false, false. Now, Dominic said the first negation is the main operator of the second sentence. So that means we need to work inside the parentheses first. So we see that the second negation covers only Q. So its scope is restricted to Q, which means that negation has to be determined before conjunction. So 1, 2, 3. So false, true, false, true. And then we have false, true, false, false, and then we negate. So we have true, false, true, true. And we see that the two sentences are not equivalent. The two sentences can't be used as substitutions, one for the other. But given what you're seeing, leave the sentence on the left alone. So let's leave the sentence on the left as it is. What would you change for the sentence on the right so that you end up with a sentence that is equivalent to the sentence on the left? Does that make sense? What are you going to alter so that you do have an equivalent sentence to the one that I'm writing right now and the one that is just above it? Does my question make sense? Tell me if it doesn't. So what should we do to make that second sentence equivalent to the one on the left? And Victoria has a good idea. So Dominic is saying add another negation to the front of the sentence on the right. And Victoria, yeah, the widest scope, right? And Victoria says, what if we swap out the I see what Victoria is saying. Okay, so here are two options. Let me write both because Dominic and Victoria have each contributed options. So but let me move things over a little bit. So Dominic says go ahead and add another negation. And Victoria says to negate the implicated conditional. So those are both clever ideas. All right, so we've got our values, false, true, false, false. And then we're just going to take all the values that were under 3 above and negate those. So we end up with false, true, false, false. And the only... and then what we can do is we're taking, does everybody see what we're doing, right? We're taking these values and just plugging them in. We're taking these values and we're negating them. And then Victoria is saying, let's take these values and negate those. So, or actually I should do this instead. Bear with me. Take these values, oops, and negate them. And Dominic says, take these values and negate. We'll just do that. That's clearer, I think. All right. So we end up with false, true, false, false. Yeah. Good. And notice that what Dominic has done is equivalent to removing the negations altogether. So you've got also this option where you're just saying P conjunction, not Q. So you're just taking the values that we had finished with and just plugging them in, right? So false, true, false, false. So, part of what we want to think about here is the myriad ways in which, logically speaking, we can say the same thing. And we're not talking synonyms. We're not talking like. We're talking identical truth values, which is crucial for us to distinguish, right? The idea here is that we've got this exacting level of truth functional identity. All right, so let's come up with some sentences then let's go all the way back up to the top. P arrow Q. So first let's do this. Do you mind telling me what your bag, your deal, your thing is? What are you really good at? Like, do you play piano? Are you really good with, I don't know, financial investing, or, I don't know what people are into. I'm really good at complaining, but that's just not going to help us here. So I'm not going to bring my stuff in. What are you good at? We need to make some sentences, I think, that will connect to your daily life. Or what do you really enjoy doing? Do you love music? Do you listen to music? Do you play sports? What's your bag, your deal, your thing? Tell me something, please. Learning languages. Okay, awesome, Dominic. Dominic, do you what are your favorite languages? Spanish and Italian. Okay, excellent. So how about this? What did you grow up speaking? Okay. So let's take those three languages. Let's think about the way that the conditional works, such that we're reminded that the conditional is on some accounts not truth functional, right? We saw that on Tuesday. But if we are comfortable with the negation on the left side of a disjunction, and we see in our sort of our ordinary thinking about these connectives, that the conditional and the negated left side of a disjunction kind of feel connected, then maybe we'll further reinforce our thinking about what the conditional does. Okay, so how about this sentence? If Dominic speaks Italian, then Dominic speaks Spanish. Either Dominic doesn't speak Italian or Dominic speaks Spanish. If Dominic doesn't speak Spanish, then Dominic doesn't speak Italian. Next set of sentences. It's not the case that speaking Italian is a sufficient condition for speaking Spanish. It's, or how about, and then let's drop down to the third row. Right, so we have, it's not the case that speaking Italian is a sufficient condition for speaking Spanish. And then I'm going to just drop the two negations off. Dominic speaks Italian and does not speak Spanish. It's not the case that Dominic doesn't speak Italian or Dominic speaks Spanish. Thoughts? I know I didn't get English in there, but I was using English in the like when you're listening to those sentences as your eyeballs are going over the notation, do you find that sometimes the ordinary English sentence and the notation you're reading feel connected and feel right? And sometimes they don't? There are some reasons that can explain that. One may have to do with the aforementioned issue with the conditional. One may have to do with what we're the ways that we're used to structuring logically our thinking. Right? So those are at least two reasons. But did you find that that was the case? Did you find yourself saying things like this? Oh, well, both Spanish and Italian share language roots. And so when you say that if you speak Italian, then you speak Spanish, I can see that being legitimate because it's not hard to sort of convert and adapt, right, some Spanish vocabulary and sentence and grammar to, I said Spanish, I meant to say adapt and convert some Italian grammar and vocabulary to Spanish. Right? In other words, you try to make sense of that conditional claim, because a part of us wants to say, well, no, just because you speak Italian, that doesn't guarantee you speak Spanish. So now you're trying to find a way to make that conditional work, because we're thinking again about that dependent relationship. What are we thinking about? So now let's come back to the truth table real quick. What are you thinking about the equivalences? So far, so good? Okay. I see Dominic's like saying, yep, seems good. If you're not, think about what's bugging you, and then let's talk about it. Okay. Meanwhile, let's call back again to Tuesday. And I'd like us to look at now the truth tables, the truth table method of determining validity, so that we can see we can see exhibited the fact that there is a problem with affirming the consequent of a conditional claim, but there is no problem with affirming the antecedent of a conditional claim. And there is no problem with denying the consequent of a conditional claim, but there is a problem with denying the antecedent of a conditional claim. This harkens back to our discussion of sufficient conditions and necessary conditions. Okay? So if that worked for you, use that, leverage that here. All right, so here are 4 arguments. Right, so premise 1, premise 2, conclusion. Same thing. I'm not going to write P1, P2 again and again, so I'm going to assume that you're okay with the pattern. Okay. So I've been kind of yapping about the truth values. Tell me first, how many rows are we going to have for each of the 4 arguments? 4. Yep. Thanks, Dominic. Thanks, Victoria. Next question. What is the set of values under the conditional for, because it's the same sentence, right? In all 4 arguments. So what are the values? Wonderful. Thank you both. Sorry, I don't know why I'm fixated on this arrow going right. So beautiful. True, false, true, 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 false, true, 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 false, true, 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 false, true, true. All right. Where we have an atomic or simple sentence, what are we going to do? What values will we put under A, B, for going left to right, argument 1 and 2? Does that make sense? I feel like the question that I asked was asked in a really convoluted fashion. Good. True, true, false, false. Thanks, Victoria. All right. So true, true, false, false, and then B, true, false, true, false. True, false, true, false, true, true, false, false. Okay. Is to look at the first argument. Is there a row on which the premises are true while the conclusion is false? In other words, is the first argument invalid? Beautiful. No, it's not an invalid argument. This argument is valid. Yay. This is an argument. We'll see this, in what is it? Should be chapter 18. We'll see that this argument is commonly called modus ponens, or mode of affirmation. It's actually a rule that we will use, conditional elimination, right? So it's a very common form of reasoning, and it's our friend. We want to use it. So hold on to that. But take a look at the second example. Is there a row on which the conclusion is false while the premises are true? And if so, which row? Yes, row 3. Dominic, thank you. Beautiful. Invalid. This is an imposter, right? Notice how similar it is in structure to the modus ponens argument. Think about it this way. Remember, we were talking on Tuesday about the fact that a condition is necessary, but just because that condition has obtained doesn't mean that the sufficient condition obtained. So, example, if I have 100 pennies, then I have $1. I have $1, therefore I must have 100 pennies. Well, no, because there are that could be false, right? I could have a single dollar bill. I could have, 2 quarters and 50 pennies. In other words, the permutations, right? I can generate a counterexample to that conclusion. So the affirmation of the consequent doesn't give you anything, right? We won't use that as a rule. Now let's take a look at the last two. We've got the negation of the consequent in the left example. So our values are going to be as follows: false, true, false, true. And let's plug them in over on the other side too, since we're already working that. And then negation A. First, so thank you. I need to be corrected. Right. Sorry. False, false, true, true. False, false, true, true. There we go. Is there a row on which the premises are true while the conclusion is false? And the answer is, oh, thank you, Arshak. I didn't see the chat. Yes, you are correct as well. Sorry about that. Right. So valid. Now, here's something interesting. Remember I mentioned earlier that the, I'm going to abbreviate this as MP for modus ponens, or mode of affirmation. We use this as a rule, but this argument form, commonly called modus tollens, it's also an argument to absurdity. It's a reductio ad absurdum. We won't use this as a rule. We're actually going to prove it. We're going to prove it. So maybe we'll work ahead a little bit to do that if you're game. So this is valid. What do you think about the fourth argument? Row. Yep. 3 again. Invalid. Another imposter. Right? So remember earlier we were, on Tuesday, we were talking a bit about how it's easy to get turned around with how to understand the conditional claim, particularly when we're thinking in terms of sufficiency and necessity. So because it's easy to get confused, knowing these structures is very helpful, right? Because then we won't draw erroneous inferences. Let me just show you real quick how we're going to prove the argument. So let's do it this way. This is argument 1. And this is argument 2, 3, and 4. We're going to prove that 3 is valid. And it's going to go something like this. It's not the only way we can work it, but it's the way that I'm going to approach things right now. What do you think? Do you notice that proving this rule involves stuff you already know? And there's one move, the move to line 4, that's new. So contradiction intro for 2 and 4. And then 4 itself is a conditional elim, which we're going to get to, from 1 and 3. And then as you saw, 3 is an assumption. Right? So I want to keep hammering away at the idea that our rules for the Boolean connectives, for the propositional logic connectives, those are truth table based rules. What do we think? How are we doing? Questions, problems, confusions? While you're thinking about that, let me take a quick look at the text. Okay, so I just wanted to check on, oh, now of course I forgot the number. I think it was 17.3, where the discussion involves sufficiency and necessity. Let's look at this together. First, I got to save these again. Save. Or I got to not save these again, but save again. Okay, so given what we talked about on Tuesday and what you've already read, are you comfortable with how you grapple with translating these sentences? What do you think? And there are a couple of approaches that we can take. One approach is to think about reformulating the sentence, right? How would we, if somebody were to ask what we mean when we say being a horse is sufficient for being a mammal, we might say, oh, well, if you're a horse, you're a mammal, right? You'd make that translation very quickly without probably even really thinking much about it, right? Do you do something like that? Or do you take the approach that involves just replacing language with the symbolic logic notation? So what are your thoughts on this? What do you think? Questions, problems, confusions, comments? Silence. Does that mean you're comfortable? How have you been doing with this stuff? Pretty good? All right, I'm going to take silence as affirmation that things are going okay. I do have a question though that I really do want you to think about and let me know, and give me an answer to. Are you doing okay with practice? Do you need more practice than is currently available? What do you think? How are we doing? I know I've generated some additional practice, right? Practice that's in addition to the text, but you may have worked through that. And if memory serves, I don't know. I'm not sure that I gave you additional practice for generating truth tables and assessments of the sentences and truth tables. So tell me, do you want me to give you more practice? Do you have sufficient practice? What do you think? Okay, so you're okay, Victoria. All right. Well, if you run out of practice, just let me know. I mean, I'd rather you have more than you can complete, just so you have a nice pool, and you don't ever, you know that it's there for you if you need it. So I'll try to generate more anyway. But as long as if you do run out before I've given you more, let me know. All right. Anything else that you're dying to talk about? I think we've got a good handle on our conditional and biconditional connectives and the symbolic notation for them, how we translate, basics of translations, the truth definitions, and constructing truth tables. So if you're good, let's go ahead and reconvene on Tuesday with I think it should be chapter 18, when we add on to our existing skill set, the skills of enlisting intro and a limb for conditional and biconditional, and then practicing with those. Okay? Have a wonderful rest of your day and a wonderful weekend. And as always, I'm here. If you have questions, problems, confusions, comments, let me know. If you can't make office hours, we can find a time to meet. Okay? Thanks, everybody. Have a good one.